This is the first 5.2 video. We're going to look at probability rules, and the first objective is to give a probability model for a random process with equally likely outcomes and use it to find the probability of an event. So we have three new terms. The sample space is the set of all possible outcomes of a chance process. Probability model gives us two things. It lists all the possible outcomes, which is the sample space, and then it tells the probability for each of those outcomes. So an event, it's any collection of an outcome from some random process. I'll give a couple example of those in a moment. So let's look at our first example. Spinner has three equal sections, red, blue, and yellow. Suppose you spin the spinner twice. Give a probability model for this random process. So here's what I mean by a spinner. It's got the spinner in the middle and there's the three equal sections. So the sample space, or the probability model, requires me to list the sample space. So I'll list out all possible outcomes from this spinner if I spin it twice. So first, here's the sample space listed out. I could have a red and a red, a red and a blue, a red and a yellow, blue and a red, blue and a blue, blue and a yellow, yellow and a red, yellow and a blue, yellow and a yellow. Those are all the possible outcomes. And next, I need to say what the probability of each of these outcomes is. And since these are all equal size, these all have an equal chance of occurring, which means there are 9 total outcomes. So each of these has a 1 out of 9 probability of occurring. So again, since they're all equally likely, then there's a 1 out of 9. The probability is 1 out of 9. I want you to notice that I wrote this probability model out in this way. Generally, the way we're going to write probability models are going to be in tables, but I wanted you to see both options. We'll look at a table here in a second, because I want you to realize that you can write the sample space in brackets, but you need to list out all the possible outcomes. Another thing about the probability of being 1/9, we'll learn in the future that the probability of getting the first red is 1/3 and the second red is 1/3, so we would multiply those together. More on that to come in the future. So let's define event A as spinning blue at least once. So now we've identified an event. It's a collection of outcomes. It's all the outcomes that have blue in it. So if we count, there are going to be a total of 5 outcomes with at least blue. 1 here, 2, 3, 4, 5. So those 5 out of 9 mean the probability is going to be 5 out of 9. So you can see the probability of event A is the 5 out of 9 total, or 0.556. I listed the 5 total outcomes that satisfy event A. That's not necessary. I just wanted you to see it. So let's look at the next objective. Using the basic probability rules, including the complement rule and the addition rule, for mutually exclusive events. So let's suppose we're rolling 2 fair-sided dice together, one that's red, one that's blue. The sample space is provided to the right. So you can see if we're rolling 2 die, there are going to be 36 total outcomes. So let's define A as the event of getting a sum of 5. Find the probability of A. So getting a sum of 5 would mean I could get a 1 and a 4, or I could get a 4 and a 1, because the color identifies which one's the 4, which one's the 1. I could also get a 3 and a 2, or a 2 and a 3. So there are 4 different ways that I could get a sum of 5, which means my probability is going to be 4 out of the 36 total possible outcomes. And you can see them over to the right here. Next, let's define event B as getting a sum of 6. Find the probability of A or B. So first, let's find the probability of what B is, getting a sum of 6. And there are, I believe, 5 different ways we can get a sum of 6. Here is one way, 2, 3, 4, 5 ways. So I've shown the 5 different ways, 5 out of 36. So now, since these events are what we call mutually exclusive or disjoint, we can use the addition rule that applies to mutually exclusive events. Mutually exclusive events are events that cannot occur at the same time. These are mutually exclusive because you can't roll a 5 and a 6 at the same time. So with that in mind, all we have to do is add the probabilities of A and the probability of B. So you can see 4/5 plus, or 4/36 plus 5/36 gives us 9/36, which is 0.25. So I want to really emphasize that this rule only applies for mutually exclusive events, which are events that cannot occur at the same time. And with that in mind, I'll introduce us to our basic probability rules, which we've already shown in practice, but I want you to see what the rules actually are. For any event, let's call it A, the probability of A occurring is always going to be a number between 0 and 1, where 0 is an event that will never happen and 1 is an event that will happen every single time. S is going to symbolize the sample space, and the probability of the sample space has to be equal to 1, which means all of the outcomes, their probabilities added together, will add up to 1, because one of those events will happen. For example, for rolling 2 die, um, we're going to get some value between 2 and 12. In the case of equally likely outcomes, which are what we've seen in the first example, then the probability of event A is just the number of outcomes in event A over the total number of outcomes in the sample space. One thing we haven't discussed is the complement rule. This symbol here, A not, is what it is. So this is the probability of A not occurring. The probability of not A is the way we would say it. And the probability of not A is 1 minus the probability of A occurring. We'll look at an example of that in a second. And then finally, the addition rule, but for mutually exclusive events, is if A and B are mutually exclusive, then we can just add their probabilities together. We'll see that if they're not mutually exclusive, then we have to add in something else to this rule later, which we'll get to in the next video. So let's take a look at the next example that will talk about the complement rule. Suppose you tear open the corner of a bag of M&M's milk chocolate candies. Pour one into your hand and observe the color. According to Mars Inc., the maker of M&M's, the probability model for a bag from its Cleveland factory is shown below. So this is what I was talking about earlier. Probability models are generally written in tables where you've got the outcome and you have its probability listed below. Explain why this is a valid probability model. So remember, probability models have to show two things. Those two things for this case, the sample space has to add up to 1. And the second thing is we have to make sure each of these probabilities are a number between 0 and 1, which you can see is the case here. So you can see each of the probabilities is a number between 0 and 1, and the sum of all the probabilities, or the sample space, is equal to 1, shown below. And that's because if you pour out a candy, you're going to get a blue, orange, green, yellow, red, or brown. One of those will happen. There's a 100% chance that will happen. So let's look at the next problem. Find the probability that you don't get a blue M&M. Here's where we can use the complement rule. Now, we don't have to use the complement rule. We could just add up the probabilities of all the other ones, which we'll do in a second. But I want to use this complement rule, and we'll define the event. We'll say B is the event of drawing a blue M&M, and we want to know what's the probability of getting not a blue. So we'll say the complement not blue will be drawing any other color except blue. So here's our equation for the complement rule. The probability of not blue is 1 minus the probability of getting a blue. So the probability of getting a blue is 0.207. If we subtract that from 1, that will give us the probability of drawing one of these other colors. So there you go. 1 minus the probability in blue means that there is a 0.793 probability of drawing a not blue. The other way to do it is I've shown over here, probability of getting orange, green, yellow, red, or brown just add up their probabilities. Since they are mutually exclusive events, we can use that rule because you can't get a blue and an orange at the same time. The probability of that happening is 0. So add up those and you get the same exact probability. So finally, what's the probability that you get an orange or a brown? So like I just said, these are mutually exclusive events, so we can use that addition rule that we've talked about, where we're just going to add the probability of an orange plus the probability of a brown because they cannot both occur at the same time. So the probability of an orange or brown is 0.329.